Okay, we're back in section 12.1. This time we're going to focus on the computer output. I know from earlier chapter, in chapter 3, when we first started looking at regression, the computer output proved to be really confusing for some students. So I want to take the time to really focus on this because on the AP exam, that's what they typically give you. So this comes from the Prezi that I posted for you guys. On previous AP exams, when students have been asked questions about inference for regression, they have always been provided with computer output. You are expected to be able to get the equation, the standard error of the slope, the test statistic, the p-value, the standard deviation of residuals, and r-squared, all from your computer output. So those are the things that we're going to go through right now looking at computer output. So first, just to give you a little bit of context of where this computer output came from. Does fidgeting keep you slim? Some people don't gain weight even when they overeat. Perhaps fidgeting and other non-exercise activity, it's going to be referred to as NEA from here on out, explain why some people may spontaneously increase non-exercise activity when fed more. Researchers deliberately overfed a random sample of 16 healthy young adults for 8 weeks. They measured fat gain in kilograms as a response variable and change in energy use in calories for activity other than deliberate exercise, fidgeting, daily living, and the like as the explanatory variable. Mini-tab output from a least squares regression analysis for these data is given. So now we're just going to focus on that computer output. And from this computer output, I want to be able to find all of these things. So we have our output for fat gain versus NEA change. Now our equation is what you've done before, and hopefully you remember how we found that part. I'm going to grab an extra pen here to help. So our constant is going to have all of this data with it. And then our x value, our variable of interest, has that goes with it. Down here is some extra things for us. Now I'm going to focus in on the ones that actually matter. Remember our equation for our least squares regression line is y hat, because it's our prediction, is equal to a plus bx. So a is our constant, so we're going to look at the coefficient that goes with our constant. So we're going to focus on this value right here, 3.5051. Then b is our slope. Now notice that that is the coefficient for our variable. If this is our variable, then the coefficient for our variable is going to give us our slope. So that would be minus 0.003 x. So that would give me my regression equation. The standard error of the slope. Now the slope came from here, so I'm going to keep reading on that line. The standard error of the slope is going to be 0.00074. The test statistic, well, if I was doing regression inference, then I'm doing it on the slope because that's what we do in AP Stats. So I'm going to keep moving along this line because I'm interested in the slope. So my test statistic is going to be negative 4.64. The p-value, again, because I'm doing inference on my slope, I'm going to stay on that line of my slope. So my p-value is going to be 0. Standard deviation of the residuals, that's going to go with this s down here. So we get 0.7399. And finally, r squared is 60.6%. The rest of the numbers given won't matter to you. Just focus on those ones.